In this video, we want to use the concepts and the basics that we learned while we are designing the rectangle class to design a different class, a class that is more complex than a rectangle class. In this class, what we want to do is to design a class that represents a point in the two-dimensional space. So if you have a point, which is represented by the x and y coordinates, what we want to do is to treat this point as an object and try to design a class that represents this point. So if you think about it, what do you want to know about this point? You have two fields, x and y, which you want to keep track of, right? The combination of x and y will represent the point in the space. You also have the constructor, which will help you build that, that point or that object. Notice here that if you don't define your own customized constructor, Java is going to provide you with the default constructor. Now, if you get the default constructor, we know that the default constructor initializes all numerical values to zeros, which means that every single point that you create at the beginning is going to be initialized to 0, 0 at the origin. And then you have the set x, set y, and go and try to set the x and y to move that point in the xy dimensions, in the two-dimensional space. So this is something that you can work with. You can either use the default class or default constructor and then go set x, set y to change the location of the point. Or you could design your own constructor, the constructor that takes x and y, and it automatically sets the point to that x and y coordinates. Then the other thing that we want to do is that we want to have two getters, right? Get x, get y to get the coordinates. Or you could just design a single get, right? A get method that is going to get point, and what it does is that it returns the x and y of the point. So that's also a possibility. You could have both of them, like the three of them, the get x, get y, or get point. The two other things that we are asked to represent is a method that is called distance to origin, which is going to calculate the distance of the point from the origin, right? So the origin is at 0, 0, and it wants to calculate that distance from the origin. Another method is called distance, and this method is going to return the distance to a different point. It doesn't have to be the origin, it's a different point with a specified x and y. Then we are asked to represent the UML diagram of this class, which we discussed before. It's an abstract or high-level representation of the class without the details of the implementation. It's just what is included in this class, right? And it's language independent, so this means it's not specified to Java. It's called UML. So any person who is using an object-oriented programming language to represent objects can read that UML and then go and represent it in the specified language with using the syntax and so on. All right, so let's start to design that UML first, all right, or at least part of it, which we are familiar with. The first thing is the name of the class. We are asked to represent a point class, so that is easy, the point class, that's there. And then we have two x and y coordinates. These are the fields, so I'm going to set them to be private with the minus, x and y, and both of them I'm going to keep them double, so this way allowing for floating point and allowing more flexible representation of points. Then what we want to do next is to start with the methods. So we are going to start with the first method, which is the special method we call constructor. The constructor is going to be public, that's why the plus. It's called point. It has to match the name of the class, and it takes two inputs, x and y, to represent the x and y coordinates. So in this case, I'm going to call them nx for input x and input y, and both of them are double to match the two fields that we had before, which is x and y. And remember, constructor does not return anything, and that's why we don't even have any return data type, not even void. All right, so that's why we don't have the colon and the return type after this. Next, we are going to represent the two getters for get x and get y. Both of them are public to be used. They take no inputs because they have access to x and y. So you don't need to provide any inputs or parameters to these two methods to operate. And we are expecting an output, of course, because they are returning x and y, which are going to be the double values, right? So colon double for both x, get and get y. So I'm going to stop here in terms of the UML representation. Let's go and implement this and then go back and think about the distance to origin and the distance methods. So here we are with the blue jay, and we are going to create a new class. We are going to call it point to represent the point object. And we are going here to represent that, or what the part of the UML that we have already designed so far. So I'm going to remove all of this and start from scratch here. So I have public class point. We said we have two fields, so I'm going to start with the fields. So I have private double x for the x coordinate. I have private double y. Then I'm going to build the constructor that we talked about. And in this constructor, what will happen is that I will say it's public, so people can use it. It has no return data type. It has to match the name of the class, point. And it's going to take two parameters, nx and double ny. All right, you can call them whatever you want, new x, new y. That's completely up to you. And here I'm going to say what will happen is that whenever I create a new point using this constructor and provide it two coordinates, what it does is that it takes the nx and go and assign it to x. So nx here, and y is equal to ny. And that's what the constructor will do to set the point with the x and y coordinates. All right. Now the next thing we want to do is to define our getters, and we will have public. It returns double, called getX. It takes no input, and what it does is that it returns, so return x. And the same goes with getY. So I have public method, it returns double, it's called getY, it takes no inputs, and it returns the y, the field y, and that's it. So let's build an application. I'm going to call it point demo, and let's try to see how we can use this this point. So here since it's an application, I'm going to use a main method. So here, public static void main string args, and then here I'm going to say, if I want to construct a point, I'm going to say point. All right, I will call it point 1 is equal to new point. Now, if I try to use the default constructor without anything, it's not going to work. Why? Because you defined your own constructor. So Java now does not provide the default constructor anymore. All right. So Java says, okay, this person knows what they're doing. They know that they can create constructors. So I'm not going to provide default constructor. It's their responsibility now. So if you want to use that, and if you hover over it, it's going to tell you I cannot find a constructor that takes no inputs. Required is double, but what is found is no arguments in your case. So what you want to do here is to provide values. So you could provide 10 and 5.5, right? And here this 10, even though it's an int, it will go and get upgraded to double because the constructor is taking double as an input. And you could say 10.0 or 10 if you want to. All right, so here I created my first point, and what I could do next is now let's for example check the coordinates. So I'm going to say system.out.printf. All right, and I'm going to say here, for example, the point coordinates are, and then I'm going to say something like, let's say 3 or 4, maybe 3.1. All right, F, and another one here. And then what we could do is to go and say point1.getX x comma point 1 dot get y. It's another method, and then semicolon here. And we are missing a comma here, so there we go. Here. All right, compile. So that's it. So 10.0 and 5.5. Notice here that even if you entered 10 as an int, compile, you will get 10.0 still. All right, so now we know that our getX, getY are working. Constructor is working. Now let's get back to the design, and let's try to think about how to create the distance to origin and the distance methods. All right, so what we want to do next is to create the two methods, distance to origin and distance, so they can work and find the distance from that point that we just created to the origin or to another point that we will provide its coordinates. So let's start with the distance to origin. You have the x and y coordinates, you have your origin at 0, 0, and then you have your point which we are going to refer to as x1, y1. Then what you want to do is to find the distance from the origin to the x1, y1 point. Now, if you remember, what we want to do is to find the distance between the x and the origin and the y and the origin of the point, and that is going to be x1 minus 0, y1 minus 0, which gives you these two distances. Then using Pythagorean, what you want to do is to find that distance here, which is the square root of x1 minus 0 squared plus y1 minus 0 squared. Now notice here that since it's minus 0, we could just remove the 0 there and call it x1 squared plus y1 squared, and then take the square root for all of this. So that's the distance to the origin. If you can find your point x squared plus y squared and take the square root of this, this is going to give you the distance to the origin. So you don't really have to do much there. You already know the x and y of the point because as a method in the class, you have access to them, right? You don't need to take inputs, and what we expect you to return is a double as a value which represents that distance. So in this case, if you want to represent this in the UML, it would be something like this. The method is public, it's called distance to origin, it takes no inputs, and it returns double as the distance from the point to the origin. So let's go and represent this. Here I will go back to the point class and try to now represent the distance to origin method. So in this case, I have it's public, it returns double, it's called distance to origin, and it takes no inputs. And what it does is that it returns the square root of the x squared plus y squared, right? Now, how do we represent this? What you want to do here is to use the math class. So I want to say math dot square root of x squared plus y squared. Now, if you remember, we also learned another method in the math class, which is called math dot pow, which is going to take a value here x and the power, which is 2, plus math dot pow, and here y comma 2. So this way it's going to represent the equation that we just talked about. I have seen people who tried to work around this and said math dot square root. All right, there's no work around this one. However, here what they did is that they said x times x, which is x squared, plus y times y. All right, which gives you the x squared plus y squared. So that's another work around this. So here we are going to use the math class that we learned. All right, so if we are, let's go back to the demo and let's try to print this by saying system.out.println. And here I'm going to say the distance to origin is. All right, and then plus. Now notice here that point 1, when we create point 1 as the object here that is referenced by point 1 as a new object of point, notice here that it has its own getX, the instance method. It has its own getY, instance method. It has its own X and Y, instance fields. And also it has its own instance method that is called distance to origin. So when I say point 1 dot distance to origin, it's understood that distance to origin method that we are trying to call here is the one that belongs to point 1, all right, or the object referenced by point 1. Okay, so this is what we meant by reference variables and reference methods. All right, so let's try and run this, and let's take something that we are familiar with. Let's say 3 and 4. So this way we can get, and we know that the distance to origin will be 5. All right, so there we go. Here we could add n for new line, and then here there we go. So the distance to origin is 5. All right, so that is something that we are familiar with, right? And of course any other point that you think of could be used, right? So there we go. Okay, the square root of 200. Okay, so that is going to give you 14.14. All right, so that's the distance to origin. Let's go back and try to think about the distance to another point. All right, so now let's talk about the distance to another point. The distance to another point, we will have the same thing, the two axes, x and y. We have the 0, 0, the origin, and we have the initial point x1, y1. And then what we want to do is to calculate the distance from this point to another point. Now notice that when we said to the origin, we didn't really have to provide you with any information because we agreed on the fact that the origin at the 0, 0. So in this case, you already know the information from saying the origin. I already provided you the information of 0, 0. Now if I ask you to find the distance from one point to another point, now I have to provide you with the coordinates of the other point. So in this case, we have to take an input of the other point coordinates, x and y. Let's call it x2 and y2. Now how do we find the distance between these 2 points? It's the same thing. You want to find the distance projected, get the difference in the x, difference in the y, and then what you have is that the distance is the square root of the difference in x's squared plus the difference in y squared. And this is actually the more generic equation. So if you plug zeros for the origin at any of these points, it's going to give you the distance to the origin. All right, so this is exactly what we want to represent. We want to take an input from the user, x and y, in this method, and we want to calculate the difference and then the square and then the square root of the whole summation of these differences squared. So in this case here we have the distance, so it's a plus because it's going to be public. We have the method called distance. It's going to take 2 inputs. I call them again int x and int y, and that's perfectly fine because the scope of the nx and ny of the point constructor is completely different from the scope of nx and ny in the distance construct and the distance method. And this method is going to calculate the distance, so it's going to return a double. So this way we have the column double at the end. All right, so let's go and implement this method. So back to the point class, I'm going to represent that new method. All right, I'm going to make it public. I'm going to call, make it return a double, the distance. It's called distance. And it's going to take input, which is a double nx and a double ny. And then we have the representation of the method itself. So in this case here, if I have this, what I want to do is to calculate the difference between the x and y of the fields and the two inputs, which are the values or the coordinates of the new point. So again, I'm going to return math dot square root of math dot pound, and in this case here I'm going to say, for example, nx minus x plus the math dot pound of ny minus y. Notice here that it's not going to matter which one you will start with or subtract, because even if you get a negative value here, you are going to raise the power to 2. So I'm missing here the 2. All right, and here I'm going to include this in a curly brace in parentheses and then 2. So again here, nx minus x or x minus nx, whatever that value is, it's going to give you positive or negative. It doesn't matter, because you're going to square that, which is going to give you a positive number anyway. So it's a positive number plus a positive number, and then you take the square root of this, which is going to give you the output or the distance here. All right, so let's go back here to the demo and let's try to use this new method. So here I'm going to say distance to, let's say here, let's call it 0 and 0 for now. All right, and then I'm going to make this distance, and here I'm going to provide 0 and 0 just to test it. So here it's supposed to give me the same output as the distance to origin, which it did. All right, now if we take another point, so let's say for example here I have 10 and 10, and then I'm going to take another point that is at, let's say what, 7 and 6 here. So here I'm going to provide 7 and 6, 7 and 6 for that. All right, and then compile, and it's going to give me 5, right? Because I know that the difference is 3 and 4, which gives me the distance. The distances in x and y is 3 and 4, and it's going to give me 5 as the distance between the 2 points. Now notice here that these 2 points, you could be very flexible. You could prompt the user for them, you could hard code the values, you could do whatever you want, right? As long as you provide this method distance with the 2 values, you're good. It's going to operate properly. You could even get these coordinates from a different point. So you could define or declare a new point. Let's call it point 2 is equal to new point. And then I'm going to set it at 7 and 6. All right, and then if I want to, let me enlarge this one. If I want to provide the points here, the coordinates, all right, so I could do something as flexible as this. I could say here, for example, point 2 dot get x, and here point 2 dot get y. All right, and then compile, and then here run this, and it's going to give you the same result. All right, now set the second point to be 0 and 0. Compile, run, and it's going to give you the new value. So that's how you think about a new class. That's how now you have a very complex object called this point, and this represents a point in the 2-dimensional space. Of course, if you want to represent in a 3-dimensional space, then in this case you will need to add a third coordinate, and then you will reflect that change on all of these methods and constructors. All right. Now, the last thing that I would like to say before we conclude this video is that what if I did not provide a constructor? All right, so I'm going to not provide a constructor. In this case, it's going to complain. It says, I don't know what that is. I don't have a constructor that takes 2 values, right? So in this case, what you want to do is to use the default constructor, right? Which is going to give you everything at the origin. Everything's going to be at the 0. x is 0, y is 0, the distance is 0, and then the distance from 0, 0 to the 7 and 6 is going to be that here. All right, so that's a problem, because now you are stuck with a point that is fixed at the 0, 0, because that's the default constructor, and you have no way to move it to any coordinates that you want. All right, and that's why at this point what you want to do is to define your own setters. All right, so you could define your own setters. All right, set x and set y. Okay, so since these are setters, they are not going to take any inputs, void and void, right? And they are not going to return. So set x, for example, is going to take a double nx, and here it's going to set the x to nx. And here the set y is going to take a double ny, and it's going to set y to this input n1. All right, so now you have a possibility to go and say, okay, I'm going to construct a point 1, which is going to be at the origin, because that's how the default constructor is working. But what I'm going to do next immediately is to set the values by set x to be at let's say 10, and point 1 dot set y at 10, and this way it's going to change where the point is by setting it to 10 and 10. The distance to origin is this, and the distance to the 7 and 6 is going to be the 5. All right, so notice here that first we didn't need the setters because we had a constructor that will take care of setting the point at any point other than the origin, as the default constructor does. All right, so in this case you know that you need the setters if you have, or you will plan to use the default constructor.